Welcome. Thank you, Emily, for the very warm introduction. And welcome everybody to Halter. These kind of talks, they're always the kind of trendy thing to do is always start with a question. So that's what I'm going to do. And the question is, what is the ideal data platform? So if we had like zero constraints, infinite money, infinite compute, like what would it look like? Maybe a bit blue sky, like what's the point talking about this? But I think, when we build stuff, we have to make trade-offs. And I think pondering this sort of helps understand like really what's the trade-off that we're making. And kind of starts to form like the North Star, like, okay, like this is the strategy for achieving as close to that as we can get. And I think to start with, it's like, why do we build a data platform? Why do people even need data? What's the point? Very broad question, obviously, but it kind of boils down to these two things. We enable people to answer questions about the business and the customers. How's the business going? Where are their problems? Do we want to A/B test something? What was the click-through rate or some shit? And also, like, kind of the modern development is bringing new products to the market, right? So doing things that people couldn't do before because machine learning is cool. Those kind of turn into like the functional requirements. Has everyone heard of this like functional, non-functional requirement kind of idea? Yeah. So that's kind of the functional requirement, and you sort of have a non-functional requirement of queries should return eventually. In a finite amount of time would be good. Ideally, the data is available very shortly after it's created, right? Like you don't want to impose, if you can avoid it, like more latency on the consumers. And ideally, we don't pay for Bezos's nth yacht. He doesn't need. So pondering that for some time, and where I kind of, I try to come up with something that looks cool on a slide and is sort of pithy and whatever. And this is kind of what I came up with. We want to provide everything for everyone immediately and forever. So no big deal, no problem, easy. No, obviously that's not meant to be like actually achievable, but like it's try to set the headspace of like how try to move towards this. Diving a bit deeper on that, like trying to make it a bit more real. Everything meaning like everything and all the same in one place from like one interface. And also by everything, I mean like, there's no data missing and it's all correct. Like that's kind of table stakes. Everyone, ideally, and I feel quite strongly about this, like ideally people don't have to go through a data team to get benefit from data. That's something I really try to knock down is like just enable everybody to access. Caveat there being PII, any personally identifiable stuff. You don't want to share that with absolutely everybody. Luckily for us, the GDPR doesn't really protect cows from their data, so we're safe there. Immediately, I kind of mean in two ways. Like, one is that yes, the queries like finish fast, but the other part is that that it's not late. And forever, I basically just mean unlimited retention, right? That'd be perfect. So that's the goal. When I go to sleep at night, I'm dreaming about this. This is what I want. No pipelines are on fire. Nobody's asking me for like some random pipeline. Nobody's asking me why it's broken. It's just everything is golden. So what can we do to try to achieve this at Halter? We have a very large engineering team, a data engineering team. It's just me. That's all the data engineers at Halter. Actually, it's more like this because I have like other software engineering type things to do. So so that's a pretty big constraint for us. Is we small team. We don't want to pay for that yacht. So what can we do? How are we going to try to achieve our dream? I'm going to skip right to the end and tell you. It's a lake house. That's sort of what we lean on quite a lot. So if the talk is too long and you don't want to watch the rest, that's the thing. At Halter, we kind of have three different categories of data that I think of. The first is kind of application app data. So that's everything about the cows, mobs, breaks, shifts, heats, health cases, matings, calvings, everything that happens on a customer farm coming through the app. Collar data is the data that we receive from our collars that we make. Get more into that later. So that's things like the movement and GPS location, guidance cues, various metrics. And at the bottom there, I've just put everything else. They're kind of on a case-by-case basis, so we sort of just treat those differently. But regardless, we lean on Athena quite a lot. Sorry for using the AWS icons with no names. And then we use dbt to sort of take the raw data sets and make them into like much richer, more useful things. Yeah, so I rattled off a bunch of jargon there and might have gone over a few people's heads. So this is part of the talk where I have to explain how dairy farms work at a data engineering conference. Right. So why does Halter need this data, right? Coming down a level. What do we do? Right now, Halter exists for dairy and for beef cows, and what we really do is help farmers maximize the amount of food that they can produce from the land that they have. And the way all of this works is, that's a dairy farm. So we've got this green box here. That's your land. Sun and rain make grass. Cow eats the grass, and after she produces the calf, produce milk. So you sell that. That's great. Obviously, you need some genetic material to make the calf. So you've got to put that in there. And when she's finished her time on the farm, and also like food. That's what it would look like in a perfect world, but in reality, sometimes we don't control the weather, so sometimes you get more sun or more rain, or not enough sun, not enough rain. Either way, so you end up having to sort of import fertilizer to feed the crop, and water to water it. And then if there's water restrictions, you just don't grow crop like grass, anything. You also feed that to your cows, and if you don't have enough food, then you'll have to buy food as well. And if they get sick, you have to pay for medicine and bills and things. And while she's sick, you can't sell the milk until she gets better. So that's like a lot of ways to lose money. So you'll notice a bunch of stuff at the bottom there, like all crossing over into the farm, and I call that the red money line, because anytime something goes across there, it costs money. Like it's not good. Kind of a complicated picture. I'm going to use maths, which should hopefully be a less complicated picture. If we think sort of about the calculus of everything that's going on here, you have some amount of money that you make in a season, and that's pretty much a function of how many days you're milking times the amount of milk per cow times number of cows times price of milk. Right? Hopefully that makes sense. Like more cows, more milk, more money. High milk price, more money. Breaking down this amount of milk per cow, it's pretty much a function of her ancestry and how much grass she eaten. Generally speaking, for your average cow, it's pretty much a function of like how much grass she eats. So energy, like mass balance, if you did chemistry, and the amount of grass that the cow's going to eat. How much is that? Well, it's pretty much just like all the grass that's there. Like they'll eat all. Simplifying, obviously, but yeah, that's kind of the rough math. So if you study these for a bit and start to think about like what variables in this equation can we like actually tune, a lot of them are kind of fixed, and what it boils down to is basically days of milk. So that's it, D, and the amount of grass that you can grow. And just to quickly cover the rest, like you could increase the number of cows you have, but then you basically just feed them more, so it's like a non-starter. Price of milk is just economics, like you can't control that on your farm. Unless you had a really big farm, I suppose. And you can tune the genetics, but like cows mature like at about 2 years old, so you can only really change that like once every 2 years. So it's kind of quite slow. So those are two big levers: is days of milk and how much grass you can grow. Right. Yeah. Probably losing people a bit. Why am I talking about dairy farms? What isn't this? What's the point? Are we off track? Did I go to the wrong talk? That's what some of you are thinking, right? Is this relevant, or are we off track? Well, yes, but no. This is actually the first challenge, the first lesson. It's how well do you know your users, really? That's pretty much what it's all about. Like, to guide everything, every decision that you make. That's the most important thing. Could you articulate the situation of your users, the calculus of how your users act to that level of detail? That's the challenge that I would put forward. The reason it's helpful, obviously, is because when someone asks for data, you just intuitively know like what they're going to do with it, and it helps just inform all kinds of the usual decisions we have to make. Right? How much latency can they tolerate? If you ask someone, "Oh, how much latency are you okay with?" They're like, "Wait, are you telling me the data's going to be like an hour late? No, that's ridiculous. I can't handle that." But if you know the use case, then you can sort of be like, "No, it should be all right." Same with pre-aggregating the data, inventing new data. Like if someone's interested in some metric, can you just make it happen? That's the first list. So with that out of the way, what does Halter do? Why do we need a data platform? What are the use cases that we're trying to? This is the other reason I had to explain how a dairy farm works. Otherwise, it's like, what is Halter even like for? And it's basically to make this slide make sense. So we try to maximize days of milk, and the way we do that is by early detection of health cases, accurate heat detection, and monitoring cows just after they calve. And the other big part of it is maximizing the amount of grass available. And if you go to our website, that's basically the top thing. Like, we help farmers grow more grass. That's what it's really all about. And from this, we start to see the data use cases, right? These are coming back to that functional, non-functional thing. These are the functions that we'll achieve. We also have a few non-functional use cases. So we have a reasonable size fleet of IoT devices that we need to keep track of. Are they on? Do they have battery? Are they charging? Not charging? Are they still working? Where are they? All these kinds of questions, and as well as our guidance monitoring. So like how well are the cows responding to the cues? Are they responding well? Do we need to tune it? And then actual like business metrics, like how many cows, how many collars, how many mobs, things like that. But yeah, so that's kind of our requirements for our data platform. A bit more detail here. So like for heat detection, cows are on a 3-week cycle. So you sort of need a few weeks worth of data to really pick that up. Ideally, that's available ASAP, because if you miss a heat and she gets pregnant later, then you basically miss out on those 3 weeks of milk. Oversimplifying, but more or less. Working with like hourly data. And accurate pasture measurement is another thing that we're working on. I'm going to skip the details because that could be a whole talk in and of itself. And for some of these non-functional use case requirements, like for the device status monitoring, like if something goes wrong with the device, we kind of need to know about it very quickly because it's on an animal. So, as well as monitoring guidance business. And then the constraints, again, just to refresh, we don't want to pay for business's yacht, and we have half an engineer. How can we do that? We had a bunch, obviously a lot of things come to mind. Mother of all Postgres nodes comes to mind. That's like 90% of the time, right? Just like Postgres is great. But again, like I don't want to choose number of nodes, how big they are. Even it being managed by RDS is still like too much overhead for me. Snowflake, I honestly don't know a whole lot about, so I'm looking forward to the next talk. Databricks is kind of similar for Snowflake. Like for us anyway. The only thing I don't like is running PySpark. Like I'd rather write SQL. Redshift, it's tricky. The main problem I have with Redshift is like literally nobody ever seems to talk about how much they love Redshift, like, which just makes me scared. Like, why? Redshift serverless and Spectrum look really cool. Serverless didn't exist when I started all this, so might have to try it out then. Instead, this is kind of the approach they come up with. So we can use S3 to store everything for a pretty long time, right? It's like S3 will store any amount of data that you throw at it. It's reasonably cheap per gigabyte to store, at least compared to like EBS or whatever you want to use for your Postgres nodes. And you can use stuff like intelligent tiering to make it cheaper. We can use Firehose to ingest our events from SNS and Kinesis. So those are technologies that we already use in the backend. So that just makes it very easy to sort of plug in and start consuming data, and kind of gives a nice degree of separation between the data platform and like the backend platform. And there's native integration there, so that's good. And then we use Athena a lot to process the data. So you pretty much have, yeah, it's serverless, which I love. Like, just it's great. So I don't have to manage anything, and it's SQL. So like, you don't have to be a Spark engineer to interact with the data. Hopefully, it's kind of obvious. Like, this starts to head towards my dream. We can store any amount of stuff in S3. It's push-based, so it's low latency, right? Like, as soon as an event happens, it goes into Firehose, and you just set what Firehose buffer size you want. And with Athena, you basically have like a gigantic Trino cluster. You just have to share it with the rest of the region. That sounds pretty good. So let's start setting it up. It more or less looks something like this. So we, connect SNS over there. For those who are not on AWS, that's like PubSub to the Firehose, and then Firehose to S3, S3 to Athena. Very good, easy. That's like an afternoon's worth of work. But we have like 60 topics and more getting added all the time and whatever. So like that becomes a bit tricky. So the solution there is just Terraform everything. Terraform absolutely everything. One of my favorite tools. Love it. If you're not familiar, it's an infrastructure as code tool, but like the best one. Like, use it. Don't use CloudFormation. It sucks. So it's very easy to add new pipelines that way. This turns out to be so ludicrously powerful that I'm going to spin 2 lessons out of it. The first one is automation, right? Given the constraint is resource, I just have to automate like as much as I can. Because we have this reusable module, I can sort of just copy paste, like stamp out pipelines like anytime someone needs new data. And there's a huge amount of leverage there. You're going to see this word pop up a lot. When I make an improvement or a change to something, it's multiplied like 50 times. So that's just epic. The other part is leverage part 2, turn your colleagues into collaborators. So now that we've got like the details of everything inside this module, right? You don't have to be the person to create the pipeline anymore. It's just a Terraform module. You get someone to put in the variable stuff, like what topic they want to listen to, what data's in there, a few other like bits and pieces, and they can do that. So now it's not just me. It's like I can get like a software engineer or data scientist to spit these out, which is awesome. I'm going to try to rip through the rest in 5 minutes. Challenges. One big one. Everything else can sort of be solved by education or tooling, but the biggest challenge we have is your data in S3 needs to be like very intentionally laid out. If you get this wrong, and I'm going to talk about that, very expensive. Yeah. Sticker shock. So Athena, not too bad, $5 per terabyte scanned. How much does S3 charge? Like $25 per terabyte per month, something like that. 44 cents per million GET requests, $5.50 per million list requests to S3. So Athena needs to talk to S3 to get the data, obviously. you know, these pricing things on AWS, it's always like hard to like what's a million GET requests? Is that a lot? I don't know. It's not a lot. That's a lot. I was too embarrassed to put the amount of money there, but you can do the maths. Real bad. So that's might be a bit hard to read. That's billion up there. Not good. dbt, good. dbt, very helpful. For those who aren't familiar, it's a command line tool that helps you write and execute transformations of the data in your warehouse. So it works very popularly used with Snowflake, I think. But there is an Athena community supported adapter out there. So for our use case, you can just write some SQL to transform the data into a format that's suitable for like that use case, and optimize the layout, right? So like some of our workloads are interested in stuff happening on a particular farm. So we'll partition the data by farm in S3. And then when you do your query, it's just grab data just for that farm. There's obviously a bit of cost associated because you're doubling the storage in some cases. And you have one big Athena query to transform the data set. But in our case, it'll be like, what did I write down here? Yeah, double the storage cost, one large Athena queries, but then you turn like 50 or 100 or 1,000 large Athena queries into like tiny ones. So like a massive speed up there. And you know, it's just SQL and like some YAML config, but that's like easy to teach, right? So that means anyone could kind of improve it, right? And yeah, that's kind of the idea. So that's lesson number 4 is turning consumers into collaborators. So not just like other engineers, but other people who use your data. They're writing SQL all day. You teach them a little bit of dbt config, and now they can go and prepare data sets. Still need guidance, obviously. You don't want people like just creating data sets with reckless abandon, but yeah, that's probably one of the most productive exercises I've had in my career. It's just teaching people how to do stuff, and it's just, again, all about leverage. Sometimes I'll give you ideas on improvements too. Been quite a few of those actually, and it's kind of an extension of the first lesson. You know, you should know your users. Speaking of improvements and usage, something to think about is how we can understand the usage of our platform. So most of the people that we provide data to, you know, you think about it, it's a scientist or an analyst or something, they're pretty much just using data to like improve processes, right? And there's no reason we can't do that ourselves. Event Bridge. So again, for non-AWS people, that's what do they call it? Event Bus? Yeah. Athena, the Athena service publishes events to Event Bridge, the Event Bridge service, every time the state of a query changes, right? So when it started running, finishes, fails, whatever. And Event Bridge has a native integration with Firehose, and hey, we just make this thing that ingests stuff over Firehose. So, you know, why don't we just do this? We can, you know, link it back, put it in Grafana, and then look, I'm happy. Like I can monitor stuff. It's very good. We can use Athena to monitor Athena. It's very good. And this actually leads into the last lesson. And it's actually just know your users again, but this time not the users of your product, but the internal users of your data. Super useful data source because you can see like how much data people are scanning, who's running the queries, the actual query text is there. Something that I like to do is sort of group by like a filtered query text. So if you've got someone doing like the same query but for different farms or different cows, grouping all those together. And then it's like, oh, I can see like 20 different people doing like the same CTE, or 20 different people doing the same, like querying the same data and preparing it the same way. Then I can like materialize that and make everybody's lives a bit easier. Or because you've spent time like gathering an army of collaborators and what did I say before, colleagues and consumers, you can also pass those on to those people and have them sort of do it. So it's just more leverage as an engineer. You don't need to talk to every single user, but you still should. But it just means you don't have to. that's kind of the summary. So the recommendation: know your users. What does your company actually do? Because that will inform the shape of the platform that's right for you. Obviously, the S3 Athena thing works reasonably well for us, but it might not for you. Automation, using tooling to multiply yourself, turn your colleagues into collaborators, make it possible for not me to do this. Consumers into collaborators, make internal users able to self-improve the platform. And the last one, know your users again, and you can use the usage data to find places to improve things. Most of that talk was quite high level, I think. Trying to bring it down with some actual little bits you can take away. Athena is great. I love it. But make sure your data is laid out right, or else you send 51 billion requests to S3. Not covered in the talk, but it's burned me so bad I want to talk about it. Managed Flink or Kinesis Data Analytics, it used to be called on AWS. No good. Don't. Flink is awesome, but not that. Athena will only run about 20 queries at a time. That's probably a big one for people. You do have to be careful about that. The flip side of it is obviously you can have one query cover your whole data set because Athena's a massive Trino cluster in the background. Be very careful about list requests. They'll hit most of the partitions in your table, and that's another way you spend a bunch of money. Or you can try using Iceberg. That should solve it because Netflix built it to do this kind of thing on S3. Intelligent tiering is good. Be careful about counted fire hoses. Try to start a knowledge pyramid scheme in your company. So just share as much knowledge. If you're successful, then everybody else does your job for you, but that never actually happens. You'll still have things to do, don't worry. That's it. Yeah, that's the thing. 2 minutes over. Any questions?